Hi, welcome back to another video. In this video, I am going to talk about center of gravity and stability. Earth pulls every object that has mass towards its center due to gravity. Let's take a simple object. Earth and object exerts gravitational pull on each other. Divide the object into small equal components of masses. These small components experience gravitational pull of Earth, provide support at center. Let us name these individual weights and their distances from center as shown here. The object experiences counterclockwise moment m1 at left side. So m1 is equals to w1 times r1. The object also experiences clockwise moment m8 at right side. So m8 is equals to w8 times r8. Since component sizes are equal, all weight should be equal and R1 is equals to R8, R2 is equals to R7, R3 is equals to R6 and R4 is equals to R5. So moment M1 is balanced by M8. Similarly, moment M2 is balanced by M7. Moment M3 is balanced by moment M6. And moment m4 is balanced by moment m5. So entire object can be balanced about its center point, which lies somewhere on center line. Let us rotate object by 90 degrees and divide the object into small equal components of masses. Provide support at center. Let us name individual components of weights and distances from center as shown here. From our previous experience, moment m1 is balanced by moment m8. Moment m2 is balanced by moment m7. Moment m3 is balanced by moment m6. And moment m4 is balanced by moment m5. So entire object can be balanced about its center point, which lies somewhere on this center line. The point at which both lines intersect is the balancing point. So I can assume that whole weight of the object lies in the center point without loss in much accuracy. This center point is called center of gravity of that object. Center of gravity is the average location of all weights within a body. If x cg, y cg are the coordinates of center of gravity of collection of masses m1, m2, m3, etc. located at coordinates x1, y1, x2, y2 respectively, then sum of moments of all the particles about xy axis is equals to moment of resultant of weight about their axis. Moment about x-axis can be written as W times xcg is equals to W1 times x1 plus W2 times x2 and so on. Rearranging the equation for xcg, we get xcg is equals to W1 times x1 plus W2 times x2 and so on divided by W1 plus W2 and so on. Similarly, we get y coordinate of center of gravity as ycg is equals to W1 times y1 plus W2 times Y2 and so on divided by W1 plus W2 and so on. Consider a beam of length 1 meter and weights as shown here. Substitute the values in the formula. We get CG as 0.63 meter from NA. Center of gravity is shifted towards the more weighted region to balance. Consider another example of T-section. Divide this section into two rectangles, rectangle 1 and rectangle 2. For these two rectangles, compute center of gravity separately and substitute individual values in formula. For a rectangle, center of gravity is located at the center of rectangle. Substituting the proper values in formula, we get x coordinate of center of gravity as 50 mm and we get y coordinate of center of gravity as 65 mm. So center of gravity of this T section is located at 50, 65. Center of gravity of whole solid is halfway between the two extreme ends. Stability. Stability is resistance to disturbance of an object equilibrium. Stability of an object can be achieved by controlling the position of center of gravity. With the control of center of gravity, object can be rotated in desired direction. Tightrope walkers balances their center of gravity by stretching out their arms or carrying a long stick. A body resting on a surface is stable when line of center of gravity intersects the base of support. Car with the line of center of gravity intersecting the base of support is stable. Car on the right hand side may tip over. The lower the center of gravity, higher the stability. Taller objects are less stable. Small shift in center of gravity will make the object to rotate or tip over because maximum length of arm is available to rotate. That's why racing cars are designed with low center of gravity. The lower center of gravity increases the stability of a car while taking a turn at high speed, and there is less chance of tipping over. Heavier objects are more stable than lighter objects. We can also increase the base of support to increase the stability. That's why taller buildings are tapered out at the top of the building. This increases the base of the support.